Hey everyone, it's good to see you. Today we're going to talk about implementation-first GraphQL and why you should use it to build your next GraphQL schema. Thanks. So let me first say a few things about myself. My name's Erik. I'm a software engineer at a company called fulfillmenttools, and I'm an open source maintainer in my free time. I work mainly in the GraphQL Python ecosystem. I joined the Graphene maintainer team a couple of years back, and since the beginning of this year, I've been part of the Strawberry core dev team maintaining Strawberry, which is an implementation-first GraphQL library for Python. And today I'm here to talk about implementation first, introduce the pattern a bit, hopefully get some of you to try it out in the future. But before we get into that, let's just talk about the general question you have when starting a new GraphQL project in the backend, and that is code first or schema first. I kind of hope that the answer after this talk will be implementation first for many of you, but let me just recap some of the basics first. And let's begin with schema first. Usually in a schema-first approach, you start by having schema definition language and writing down your entire GraphQL schema in that. So for example, in this example, we have a type query and a type user with fields ID and profile picture. And after that, we have a code generator running to generate some TypeScript type in that case for our user, having the equivalent fields of ID, in this case type string, and the profile picture of type image. And now to fetch your data in a schema-first approach, you would use some kind of resolver. For example, this style, where you have your query fields over here, resolving the user, and your field resolvers for all of the fields that do not use a default resolver. Maybe need to do some extra fetching where you can call some external services to get your data. And the biggest property about this approach is that resolvers, in this case, are separate from type definitions. And when that happens, there's some degree of redundance and duplication. I'm going to show you that on my example over here. For example, you have the field profile picture, which is defined over here. You have a return type image, and you over here name the field name. And in the schema, it's also defined in the same way. You have your profile picture and your type, as well as the field names and the field types. Again, when you look at the code gen types, the same thing happens. You have your user type. It has fields that are equivalent to the schema types. So basically, your type definition is replicated across 3 places and fragmented across 2 places, because you need to check the resolver to see which fields have a special resolver, and you need to check the type definition to see the origin types as they appear in the schema. Right. Code-first approach kind of alleviates that problem a bit by not having to write schema definition language in the first place. You just write an interface, and in this case, in the reference implementation, you define your user type like this. So you start off by creating a new GraphQL object type, and then you create a dictionary of fields, including the ID and the profile picture. And for each of the fields, you define a type. So first of all, the ID is of type GraphQL integer, and profile picture is of image type, which is another GraphQL object type. And again, over here, we can see a separate resolver function and separate type definitions deviating, potentially deviating from the TypeScript types. And with this duplication we have over here, there's always a risk of inconsistency. And let's have a look at this example in a modified form. I switched up some types. Maybe you can spot the mistakes. The first problem you could have is that the TypeScript types deviate from the actual GraphQL object type. In this case, the ID is of type integer in the GraphQL schema, but in your local implementation, it's of type string. Another problem that could occur is argument types. For example, you could have the argument resolution for a profile picture in the resolver if you want to resize your profile picture for a specific view. And you could make a typo over here. The argument is called resolution. In the resolver, it's called resolution. And there's no type safety between these 2 fields. Actually, you won't realize until you run the application and run the resolver that actually this field is undefined. There will be no error before that. And there's a couple of other problems with that, because there's no native validation here. So between this and that, there's no connection in your code. The checking is only done during GraphQL request execution by the execution engine, which later does the type inference. In a different example, we have a user resolver that is also schema first, like the example I showed before, and there's additional cases for inconsistency. So for the profile picture field resolver, for example, there's no guarantee that the image type you chose over here as the return type is actually representing the image type in the GraphQL schema. And there's no guarantee that the root type of user is actually representing the root type that you're getting in this resolver. Because it's not connected, it's just something you write over there. The true source of truth is in the GraphQL schema. And this is one of the big problems of conventional GraphQL frameworks. They don't ensure consistency between schema types and resolvers, and thus type safety is not guaranteed. Now you might wonder, GraphQL in itself is a type-safe specification, or the execution is type-safe. But I'm talking about type safety during implementation here. So type safety in execution is of course guaranteed, but it might lead to runtime errors if type coercion is impossible. For example, if you return an integer for a string. That might be possible in some implementations, but the other way around, a string for an integer will mostly be a problem, and it will lead to a runtime error, breaking your clients and breaking your servers. And ideally, since this error occurred during implementation, you also want to catch it during implementation. And let's first recap on the two approaches I've shown you, schema first and code first. First of all, schema first doesn't work without a code gen. It always requires an extra generation step, which is time consuming. Maybe there's some future potential for that when you use GraphQL LSP. Maybe there's some extensions for schemas in the future, at least hope for that. If you haven't heard of it, please check it out. It's very great for building your front ends and building queries. But code first alleviates the problem by just defining your types in TypeScript. Then the next aspect is the duplication. Both code first and schema first lead to duplicated information between schema definition, type definition, and resolvers. And this, in both cases, may lead to inconsistency between the resolvers and the schema types. So surely there must be a better approach, right? And I want to show you an example from Facebook. It's from 2016, so a long time ago. And this is a PHP-based implementation of GraphQL. To be precise, it's in Hack. So it's type PHP. And over here we can see our user example again. And the user in this case is annotated. So first of all, we annotate the user with a GraphQL object type annotation. And we're passing over a type name for our schema. And then we annotate the profile picture function as well. So in the first version, or at first sight, it looks very similar to our schema first resolver we looked at. But the difference is that this is actually the only type definition. This definition is the single source of truth for the schema type and for the resolvers. So based on this, you can infer GraphQL schema types containing exactly the fields defined in here. So it will contain a profile picture field and an ID field in this case. And this solves one of our problems, basically. It solves the duplication problem because you do no longer have two separate sources, your resolver and your type definition, and they cannot become inconsistent in that process. And the beauty about this is that this implementation basically infers all of the schema types from your type annotations in your native language. So in this case, the profile picture is another GraphQL object type, which is then connected to the user type, and this is reflected in the schema. This makes this approach type-safe by design, because whenever you try to return something different from this resolver, you will get an error by the compiler saying, okay, you need to return a profile picture at this place. And whenever you change the annotation of the profile picture to something else, you also get an error, because the getProfilePicture function, of course, returns a profile picture. If you were to completely change it, it would result in a different schema, and thus not leading to inconsistent states, but just a different schema overall, which you would realize when checking in your code. And this concept is what we call implementation-first GraphQL. Let me expand on that a bit. Basically, the concept of implementation-first GraphQL is that you want to derive your schema from the implementation of your types in the code. And basically, implementation-first GraphQL generates GraphQL types from the native fields and types and methods of your code base. And to do that, it might leverage annotations or reflection. As you've just seen in this example, we had the GraphQL object type annotation and the GraphQL field annotation. And based on these annotations, you're able to infer an isomorphic GraphQL schema. So basically, for each Hack type in this case, or TypeScript type, you receive a GraphQL schema type. And this makes it all type-safe by design, solving our problems I've just presented in the first step. And in order to use implementation first, there's a couple of frameworks out there. One of them is Strawberry, which I am working on. Then there's Hot Chocolate, which has an annotation-based version of using implementation first. And then there's Graz, which is the newest kid on the block. It's created by Jordan Eldridge. He's also here today. And he coined the term implementation first, actually. I think he was the first one to call this style of doing GraphQL implementation first. And just to categorize it, usually these frameworks are referred to as code first. But we think it kind of deserves its own category for just being so different and more compact and concise to use. So for now, let's switch to Strawberry for a bit, because I can show a bit more examples. This is our schema example in Strawberry. Again, you have your type annotation, you have your field annotation, and this exactly builds the same schema as seen in our example. You have methods which refer to fields, as long as they're decorated with fields, and all other fields on this type are just included in the schema by default. And the beauty about implementation first is that whenever you have a field resolver, you have some kind of self-reference, or this in other languages. And it's guaranteed to be of that type user, so you're always working with objects on your types. As opposed to, for example, traditional schema-first approaches where the root type might differ from your actual type that you receive in your resolver. Another example here, right? This is deviating. I'm sorry about that. So self is guaranteed to be a user object in an implementation-first framework. Another thing you can see over here, arguments are also super simple to implement. You just add an argument to the method, and the argument is reflected in your schema with the same type and the corresponding documentation. Next, you might define some other fields. For example, you might define a list of friends, and it's as easy as creating a new method, annotating it with list, user, or none to define the nullability. And basically, what Strawberry does for you is it infers the schema type based on the type annotation. Another thing you can do in implementation first is exclude fields from your GraphQL schema. And again, it's as simple as just annotating the field as private, and then it's excluded, but you can still use it in your resolvers. It's a common case you have in many GraphQL resolvers when you pass on information from the root type to a child type, but it's not part of your schema, or it's not resolved. And usually, you kind of alleviate that in schema first by extending your codegen type with another field which you pass down to a different resolver. And here you just have a type save on the same type as it is in your schema. You can also easily define scalars in implementation first. And scalars basically correspond to primitives or types in the language you're using. So in Strawberry, you're able to define a big int scalar like this. It's of type integer or string in Python. So we have the type validated. You add the serialize and pass value functions, just like in the reference implementation, and then you're ready to use it as a type annotation. And whenever you use it in Python, it will be recognized as a union of integer or string, so you know how to handle it in your code base, and you can always be sure that it's mapped to the correct type in your GraphQL schema. The next feature of implementation first is easily designing and defining queries and mutations, which are basically also just fields on object types, right? Mutation is an object type, a query is an object type. So you again just define a type query in this case. You have a user field, or in the mutation case, you have a create user mutation, and you can create methods or fields to actually define what data you can fetch or mutate in your schema. And over here, you can see how to work with implementation first types. You just return a new type, instantiate it with the exact keyword arguments in Python terms, and then go from that. And this is basically implementation first in a nutshell. And a lot of the concerns I hear are related to being easy or hard to read when you are not used to implementation first. So it might be difficult to work with. And this is a concern I actually hear a lot. It's the same for code first versus schema first. And like my clear experience from working with implementation first for many years is no, it's not actually harder. You can trust me on that. But no, let me show you some examples. So let's look at Strawberry. You've seen this a couple of times now. And if you look at a different language, maybe hot chocolate, right? It's the same pattern. You have a user class, you have a string of type, you have an ID of type string, you have an ignored field password hash, and you have another field, which is the profile picture with the resolver. Another example is Graz in TypeScript. You have, again, your user class, you have your ID field, the password hash is ignored, and the profile picture is of type image again in your schema. And you can see there's some slight differences between it because it adapts to the flavor of each language. But that's actually an advantage of implementation first, because it makes you work in your language without leaving the kind of space of thought you have when working in TypeScript or you have when working in Python. It's just very fluent because you don't have to think in a different schema or language at the same time. And this is what I kind of like to call thinking implementation first. You start off by just writing down your types, thinking which fields do I want to expose on my GraphQL API, and writing down your resolvers. And you don't have to do much switching. You don't have to do any code generation in between. It doesn't interrupt your workflow at all. You can just write it down and you have your schema working in a second. I can show you later if you have some time left on a playground. It's really very fast and simple. And the main observation here is that when you are working with data objects in some kind of framework, they already form some kind of a graph. And with implementation first, you simply choose which fields and methods to expose in your GraphQL schema by annotating them or by marking the type as a GraphQL type. And once you get used to the pattern, from my experience, I've been switching many projects to implementation first in the past, and people usually get on board really quickly. So it takes them a couple of days to understand the pattern, and it's not a big it's never been a big problem understanding which resulting type you will get in your schema or where your types are at. You just need to follow a couple of best practices. So first of all, the general best practice, keep your resolvers slim, so you don't have your type definitions full of logic. Maybe 10 lines max per resolver is a good rule of thumb. And the second rule of it all is just to keep working with the pattern and read the documentation, which is just a general best practice. But usually it's very intuitive. And when you look at the code base, most of the people experienced in GraphQL already have no problem working with implementation first. And if it's still unclear for new developers who are just maybe new to GraphQL, have read the schema definition, are able to understand the schema, able to read a schema, you can anyways just check in your SDL as part of a pull request, just to make it more clear for new people to understand the schema, which is a best practice in general. I really like doing that, to have a quick overview of any changes in any pull request. So this will make it easier for anyone to work with that and just get accustomed to the new pattern. And we have some time left, so I'm going to show some more advanced patterns on implementation first. The first one is native generics, one I really like, because in GraphQL you have many types like connections, which are reused throughout the entire schema, but in traditional schema-first approaches and in many code-first frameworks, you have to redefine your connection type for each and every type that is actually paginatable. And in Strawberry and in other implementation-first frameworks, you can just use the built-in generic feature of your language to define a generic connection type. So over here we have our connection. It's generic on T, and it contains a list of edges, also of type T. And then we can add some extra resolvers. This is a very simplified page info version, of course. In real life, it would be a lot more complex, containing more fields. But very simplified, you could define general operations on your generic type you could reuse throughout your entire schema. For example, here, setting the end cursor, because edges is always guaranteed to be a list on the connection type. Then, using the generic is as easy as just plugging it into your query, defining one field with it, and it gets included into your schema like this. So a user connection and a user edge, and you have to do nothing more than to use it. And another advanced pattern I really like, it's a bit more complicated. I'm going to show it to you. It's Strawberry specific. We introduced it last year, and we've really received a lot of good feedback about that. It's called field extensions. And a classic use case for field extensions is when you have some kind of part of your schema that is that you want to automate away. So basically, you're starting here with a create user mutation. It takes a create user input and a create user response. It's a basic input mutation pattern. And somewhere else, you have defined your create user input. And basically, in implementation first, it would look something like this. So you have a create user input, and then you define your mutation below that. But this is kind of annoying, because I have to define my mutation here and then my input somewhere else. Sometimes I just like doing this instead. Just defining my mutation, having my inputs on there, and then returning my response. So I don't have to separate my type definition for the input from the mutation itself. And this is where field extensions come in. Field extensions are basically a static contract ensuring that whenever you have a method like create user with your field's name and email, it will always ensure that these fields are present, but it can modify the appearance of that method in the schema. So with the input mutation extension, it would actually take these two arguments and transform these arguments into an input type, which would then be present in your schema. And it will take care of all the conversion and mapping. You could even do the same for a response, for example, catching any errors, putting it in the response if you're using the typed errors pattern. So this is a very new pattern. I'm really curious to see what else comes up. This was our first use case for it, but it's just new and emerging, and it's something you can only do with implementation first, because this is the only way to really work with your type definitions on such a low level, while actually ensuring type safety all the way through. And this is basically what I had to tell about implementation first. Let's see a quick comparison. You had our problems with the schema first and code first approaches, and implementation first basically doesn't have any more problems with duplication or consistency, and solves these approaches by providing just an intuitive way to work with your GraphQL schema. So why should you use implementation first? In my opinion, it's intuitive, and it's a very fast approach to building GraphQL APIs. You don't have to switch around files. You don't have to work with multiple definitions. You just have to think in your language that you are currently using, and you can rest assured that the GraphQL schema, is taken care of and it's properly typed. And it always leverages the native language's features, also solving our problems of duplication and inconsistency. Implementation first is production ready. It has been in production use for years throughout many companies. So especially in Python, it's been around. Strawberry's been around since 2019 or 2018, I think. So we have a lot of experience working with it, and there's a lot of feedback in here. We're taking great care of the developer experience, and our feedback generally is great, and people like switching from older frameworks like Graphene to Strawberry and having a better experience. And the last advantage is, of course, implementation first is type safe by design. You don't have to take care of any type inconsistencies, and it's just pleasant to work with that. So let me just give some credits, first of all. I want to give some credits to Jordan, because he created Graz, and he also, just give a hand for Jordan. He also coined the term implementation first, also gave some input to this talk, so I'm really grateful for that. Then also of course, Michael Stipe from Chili Cream, who also helped in creating and shaping this talk. He's one of the people working on hot chocolate. And then, last but not least, there's Adam D.I. Kramer's talk from Meta, from GraphQL at Facebook from 2016, which I used for the example I showed you throughout the talk about the user in Hack. You can check that out via the QR code if you're interested. I'm going to leave that up for a second. Other than that, thank you. And you can check out the docs if you want to learn more about implementation first, or I'll be around in the lunch break. Happy to discuss anything. And now I'm happy to hear your questions. Thank you.
So you start with an implementation first design. Do you ever have to generate a schema?
You don't have to. So the framework takes care of that. And once you do introspection, of course, internally, your implementation first schema is mapped to a GraphQL schema. So this is all happening internally. You don't have to take care of it. If you want to generate a schema, like I showed you for checking it in, you can do that, but you don't have to.
Thanks.
So in terms of, like, for example, duplication, so maybe this question is more related to Graz or Strawberry. So this is only for implementing on the backend, right? Like the server.
Yeah,
but
exactly.
Sometimes you also need to share the same types, or for example, TypeScript more related to Graz is that you will have to build the same types on the front end. So do you have any experience, for example, on that, or maybe Strawberry with Django? Mm-hmm. Or that you can generate, or are you able to use the same type generated?
So I don't think we have any experience with using Django types in the front end. And for the front end, implementation first doesn't really exist. So if you want to work on your Apollo cache and define some new types right now over there, there's no way to build some extra resolvers in implementation first. I think it's a great potential if you're working on heavy front-end, heavy code bases with a lot of front-end resolvers. But I think in general, it's not been that much of a use case so far.
Got it. Yeah, thank you.
Thank you. Yeah, behind you. Wait, let me pass it on.
So yeah, I think I was a bit unclear on code first versus implementation first, which I kind of like as a new term, but is it that code first is not necessarily type safe and implementation first is?
Yeah, that's one of the differences, and the other difference is that basically implementation first derives the schema types from your code base, while code first is usually annotated to say, okay, this is a GraphQL object type, this is an integer, and so on. I have an example in one of my extra slides. Just give me a second. For example, from type GraphQL, which you might know. So over here, this is like a classical code first approach nowadays. You would go ahead, annotate every field with its ID and so on. And what implementation first does instead, it goes ahead and infers that type basically from your type annotation in TypeScript without having to annotate anything further.
I see.
And that works for lists and complex types as well as for enums and so on and so forth.
Got it.
Could you use them?
Right. Sorry. So it's the fact that in frameworks like Strawberry, the annotations are simpler and just say like GQL type, and the name and type of that are inferred.
Exactly.
Whereas in code first, you have to specify things, and therefore it can be wrong.
Yeah, exactly.
Or drift. Okay.
Yeah. Well, I'll pass it on to the back. Right. I'll do a bit of running today.
All right, just a quick question. So is it hard to find where your single source of truth is with this approach? If you have a very, very large code base, right, you're going to start looking for where your schema definitions are coming from, essentially. Whereas with a schema-first approach, it's quite straightforward where, your type definition is coming from.
So with implementation first, you should, of course, have some kind of structure in your code, some kind of layering, whatever, so it's immediately obvious where your GraphQL implementation is sitting. And if you follow the best practices I mentioned, if you keep your resolver slim and factor out business logic into separate services, then you could have slim type definition files with slim resolvers, and they would sit in a file similar to how your schema definitions sit in some kind of file or package and module in your code. So I'd say it's very similar to schema definition.
Okay.
Any more questions? Yes.
So let's say we already have a schema and I have a couple of interfaces in my schema, and I want to introduce a new user, let's say business user. I want to make sure this business user extends the existing user interface. How would that work?
So basically, you define a new type in Strawberry or in Graz. You would annotate it not with strawberry.type, but with strawberry.interface. And then you define your new type business user and annotate it with strawberry type and just natively extend the interface type just by usual extension, how it works in your language. Yeah.
You're basically saying the source of truth is also tied to your programming language in this case, right?
Exactly.
Okay.
Yeah, Jordan.
Can I add something? I wanted to
Sure.
to the question about like the single source of truth. I think there's actually something even more powerful that implementation first can do, which is the system actually knows the connection between the schema and the implementation. And so, like if you say, oh, I'm accessing a user, where does that live? You can actually have tooling that has a click to definition in your client. That's like I click on the user, it goes through the schema all the way into the implementation first code. This is something we talked to Patrick about doing in Strawberry. This works in Graz. But you can go straight through the click to definition in your client. You're jump straight to that like method in your server code. And so yeah, like within your IDE. And so the single source of truth is actually very clear, even more clear because you don't have this indirection via the schema.
Right. Thanks, Jordan. Any more questions? All right, then. Thank you for hearing about implementation first. If you have any more questions, just feel free to come up during lunch and happy to chat. Thank you.